One of the really big advantages that chemical engineers have in looking at energy efficiency is that they've learnt a lot about analysis of processes, and so they're well tuned to thinking about systems and understanding the complexities and the interactions. At the same time, a lot of chemical processes, say in an oil refinery or a chemical plant, are very energy intensive. So from that point of view, there are very large savings to be made. A lot of chemical engineers are very excited by reactants and catalysts and things like that. And it's important to recognise that using those kinds of solutions can reduce the total flows of material, which in turn can reduce the amount of pumping and fan energy and just management of materials. So there are a whole web of benefits that can flow from optimising the chemical process.
Hi, it's Francis Barham here. I'm a Director of Innovation Strategy for Insight Energy Solutions. I'm here in Pilbara in South Africa at a copper mine. We're doing an environmental management project to reduce energy use and costs at this mine.
Pilbara Copper has a smelter which smelts around 60,000 tonnes of copper a year. The first thing we did was do what was called an energy balance, where we looked at all the flows of energy in and the flows of energy out, and we applied that to cost. So we did a cost of energy in, cost of energy out. And what it showed was that they could save around 30% of their energy costs by targeting higher energy intensive processes. We found 3 metallurgical processes that could be optimised. The reverb furnace, which basically takes in the ore and smelts it. In that process, liquid oxygen is supplied to the furnace to improve combustion and raise the temperature of the burning. And what we found was that they basically were burning too much oxygen than they actually needed. And we showed the client that basically if they reduced the amount of oxygen, that the contract actually would save them around about $500,000 a year. But it wouldn't actually impact the chemical process that was happening in the furnace if they were able to manage their fan supply to the furnace. And we worked with their chemical engineers to resolve that design issue and essentially save them around about 2 tonnes of oxygen a day, and associated with that about 5 tonnes of coal.
On energy efficiency, probably amongst the shortest payback opportunities that I see routinely day in, day out is waste heat recovery. So capturing that heat and then reusing it back in, you're able to then reduce the amount of heat that you need in the front end. And so, paybacks of 3 to 6 months at times, which is a fantastic economic proposition. So a really quick example is someone's consuming natural gas to make heat. There's absolutely no reason at all why they should just be burning that natural gas to make heat. There's a huge opportunity to put it through a cogeneration system, so you can almost instantaneously double the amount of energy you're getting out of the same number of molecules to generate electricity, and then from the waste heat associated with that engine or cogeneration system, generating your heat as well. People shouldn't just be burning a fuel to get heat. You should be looking at how can you extract more energy, more heat, more electricity, more power from the same amount of energy. So what can we do as engineers? Be aware of the cutting edge technology so that when you do have these combustion processes, you're not creating a bigger problem through emissions to air.